Hello students. So in this session, we are going to talk about your lab program, okay? That is draw a simple shaded scene consisting of a teapot on a table, okay? So in this program, okay, we are going to use a particular teapot, okay? So, and that teapot will be kept on the table, okay? So you can see this particular output here. Okay, so here a particular wall will be drawn. Okay, two walls will be drawn and one floor will be drawn. Okay, and on that floor we are going to keep one table, and on that table we are going to keep a teapot. Okay, and on this teapot you can see a kind of reflection that you can observe. Okay, that can be achieved with the help of applying the light, okay, on it. Okay, so a kind of a light and material interaction can be observed on this particular region. Okay, so in this particular program it does not have any kind of algorithm. Okay, it does not have any kind of algorithm. So here we are simply using the light, okay, light sources and material properties. Okay, and we are going to see the light and material interactions with the help of some of the OpenGL commands. Okay, so I'm not going to talk in detail about the program, okay, but wherever we have used some set of a new OpenGL commands, okay, that I'm going to elaborate, okay. The first and most important one is push matrix and pop matrix. I hope you have observed this particular command in your second lab program, that is rotation of a triangle, okay. So for that purpose only I have taken the same example, okay, the same example, okay, so that I can explain this push matrix and pop matrix. Okay, so what is this push matrix and pop matrix? As we already seen, in the stack operation we will use push and pop. Okay, what is the role of this push and pop? We are going to remember, right? It is used for remembering the elements that we have pushed, okay, and we are going to eliminate, okay, those elements which have been stored, okay, or means which have been remembered. Okay, so in the same sense here we are not pushing or popping any kind of single elements. We are going to push the matrices. Okay, so what is that matrix? So here we are going to push the 4x4 homogeneous coordination matrix. Okay, so what is this push matrix and pop matrix? Assume that if this is the triangle, okay, so before applying any transformation on this triangle, okay, it will looks like this, okay, which are the blue color. Okay, for our purpose we have applied the color blue. Okay, so once I perform the transformation on it, okay, once I perform the transformation on it, so now it is going to get changed, right? Its orientation will be get changed. So here this particular rotation about a fixed point is the thing, but we have applied the first of all we have applied the inverse translation, then rotation, and next one is positive translation. Okay, that is there in your second lab program. I hope you have gone through, and about that we have already discussed in the module 2 and module 3. Okay, so in that, whenever we perform any kind of transformations on any object, it is going to lose its originality. Okay, and it is going to update it with the set of values which whatever is applied to whatever is applied on it. Okay, for example, if this is the triangle, okay, after performing the rotation we will get this triangle, but we are not going to see this triangle. Okay, means it has been rotated, so it is not going to maintain the status of that one. So to maintain the status, okay, that is the thing. But whenever I'm applying the transformation on any object, okay, after the transformation, if I want to see the original orientation of that object, so for that situation we are going to use the push matrix and pop matrix. Okay, so let us assume this figure. Okay, so here assume that this blue triangle is stored in this matrix m1. Okay, so m1, so that will be pushed. Okay, pushing means what? I am remembering the status means what? Assume that its replica will be, okay, will be stored here. Okay, on that m1, okay, on that m1, okay, I am going to apply the set of transformations. So I can use either translation, rotation, or scaling, or combination of all these three. Okay, once the transformation has been applied, okay, so it will be drawn again. Okay, that particular object, okay, that is the triangle will be drawn again. Okay, so with the applied transformation on it. Okay, so we will get this red triangle. Okay, so after this particular red triangle, okay, so we are going to pop that one. We will pop means what? So this M2 will come, okay, on our screen. Okay, it will come on our screen. Popping means what? Execution, right? So this particular rotated triangle will come, okay, in front of our screen. Okay, after this, what is the next element? That is M1, right? So M1 will be popped. Okay, so that we will get the copy that we have stored, okay, before applying the transformation. Okay, so that will also be displayed. So in that, so with the help of this push matrix and pop matrix, okay, we can remember the orientation, okay, the shape and size of the object before applying the transformation. Okay, so before and after applying the transformation. Okay, so this is the role of push matrix and pop matrix. So here the sequence that we are going to maintain whenever we are using the push matrix and pop matrix is, the first one is, first will be user defined function, that is draw. Okay, let me assume that draw underscore triangle. Okay, that is the first one. After that we are going to use the push matrix. Okay, push matrix. So it is going to hold the status of that draw underscore triangle function. Okay, what is the next one? We are going to apply the set of transformation. It may be GL translate, GL rotate, GL scale, okay, any of them. Okay, after that we are going to call GL pop matrix. Okay, we are going to call the GL, sorry, we are going to use the GL, we are going to call the draw underscore triangle. Okay, draw underscore triangle. This will be used when after performing the transformation, okay, we have to draw that, right? We have to draw the object, okay, after performing the transformation. So we are going to call the draw underscore triangle. After that we are going to call the pop matrix. Okay, so this is the sequence, okay, that we always maintain. What is the first sequence? What is the first step? First we are going to use the command, first we are going to use draw underscore triangle. Okay, second one is GL push matrix. Third one is applying the transformation functions. The next one, fourth one is, again we are calling the draw underscore triangle function. And the fifth one is a GL pop matrix. Okay, so this is the push matrix and pop matrix. Okay, so in this particular program, okay, as I said that we are not using any kind of algorithm. It is completely based on the light properties and the material properties that we have already discussed in the module 3. Okay, in the chapter illumination models, okay, and surface rendering. Okay, so I hope you can recall, okay, in the lighting model, we have used the Phong lighting model. Okay, so in that we have used ambient, diffuse and specular. Okay, so, and along with that we have used some attenuation factors. Okay, uh, and ambient, diffuse and specular, okay, that we have used. Okay, and along with that we have studied some of the light sources. Those were point light source, distant light source and spotlight. Okay, so here in the program, whenever we are using the light, okay, whenever we are using the light, we have to enable, okay, first of all we have to enable that light source. Okay, enabling the light source is nothing but you are switching on the button. Okay, switching on the button, okay, means whenever you are entering into the room, okay, if you want to switch on, okay, the bulb, okay, so you have to switch on the button, right? So then only the light is going to glow. So that kind of enable operation we are going to use. So within that we are going to say that which light source that I want to enable. Okay, so in the OpenGL it is going to provide us 8 light sources. Okay, 8 light sources which will start from 0 to 7, means GL underscore light 0, GL underscore light 1, GL underscore light 2 up to GL underscore light 7. Okay, so in these 8 light sources, okay, I can use of any types, means I can use it as either point source, I can use it as a distant light source, or I can use it as a spotlight. Okay, Next one, after enabling the light source, okay, so here GL light, okay, in the light, okay, so here either you can use the integer or the floating point values, okay, so here GL nm, okay, so light number, okay, means it is says that what is your light number, so that is the but GL light 0, okay, light 0. What is the next one? Next one is nothing but p name. Okay, p name is nothing but the properties. Okay, the properties that you are going to apply for your light. Okay, means the red, green, and blue combination. Okay, and whether it is ambient, diffuse, specular. Okay, all these things will come under p name. Okay, and the values that you're going to pass to that. Okay, which will comes under param. Okay, so this is the a kind of prototype for your GL light command. Okay, either you can use this command or otherwise you can use this command. Okay, so in this command we are going to use the v. Okay, v is nothing but it is a pointer to a variable. Okay, so instead of mentioning each and every values here, okay, you can store the values in the array. Okay, and that array location that you can pass over here. Okay, the pointer can be used. Okay, with the help of that pointer you can access that particular array. Okay, so light num is nothing but it may be light 0, light 1, light 2, light 3, okay, up to light 7. Okay, whichever you have used. Okay, if you are using light 0 means that only you have to use. Okay, if you are using here light 0 and if you are using light 1, okay, it is not, it is inappropriate. Okay, so whatever the light that you are going to use, that should be enabled. Whatever the light that you have enabled, that light only you have to use. Okay, and here p name, okay, we have the properties that is GL underscore ambient, GL underscore diffuse, GL underscore specular, and GL underscore position. Okay, which indicates that this is the ambient light source. Okay, which indicates it is a uniformly, it is going to distribute the light, okay, in all the direction. Okay, diffuse, okay, diffuse light source in which the light is going to fall on the surface, which surfaces are rough in nature. Okay, then the specular is nothing but it is going to fall on that surface which are smooth in nature. Okay, so along with that we have some other parameter names. Those were GL underscore spot underscore direction. Okay, this command will be used whenever we are using the spotlight source. Okay, so it is going to give the direction. Okay, so in which place, okay, in which spot, okay, you want to throw the light. The next one, spot exponent. Okay, so it will be used, okay, for the exponential values for your spotlight. The next one, cutoff. Okay, so this is the cutoff angular, okay, for your spotlight. Okay, means you are going to increase the you're going to decrease the mouth of your spotlight. Okay, means that cone, okay, that cone mouth we are going to reduce. Then next we are going to use this GL underscore constant underscore attenuation. Okay, so that is KC, linear attenuation, that is KL, and constant attenuation, that is KQ. Okay, I hope you remember in our spotlight we have used the equation that is for the attenuation 1 divided by A plus BD plus CD square. Okay, where D is nothing but the distance between the light source and the material. Okay, and A, okay, A is nothing but your attenuation. Okay, and B is nothing but A is nothing but your constant attenuation, B is your linear attenuation, and C is your constant attenuation. Okay, this A, B, C together we call it as a softening coefficients. Okay, we call it as a softening coefficients. Okay, so these are all the light properties, okay, or the light OpenGL light commands. Okay, now next one is a material. Okay, for the material, okay, we have three parameters. The first one is phase. Okay, the second one is a parameter name, and the last one is values for those parameter. Okay, so either you can go with this particular command or you can go with this particular command. Okay, where we are using the v. Okay, as you know, v is nothing but it is a pointer to a variable. Okay, so in particular variable you are going to store the values. Okay, and its address will be used to fetch the values. Okay, so face. Okay, in the material, okay, we have three types of faces. Okay, that is, it may be GL underscore front, GL underscore back, or GL underscore front and back. Okay, which indicates that, so here on which face, okay, I'm interested to see. Okay, I want to see this light and material interaction. Okay, so if I'm interested only on the front face, then I can mention the GL underscore front. Okay, if I want to see the light and material interaction in the back face, okay, then you can mention GL underscore back. Okay, if you want on the both side, we can mention GL underscore front underscore and underscore back. Okay. The next one is a P name. Okay. In the P name, okay, we have this ambient, diffuse, specular, shininess, and emission. Okay. So I want you should go through that Phong lighting model, whatever we have discussed in the module 3. Okay. Once you understood that concept, you can easily understand this concept. Okay. So actually this lab program is the continuation of your module 3. Okay. So here ambient, GL underscore ambient is nothing but your KA. Okay. Next one, diffuse is nothing but your KD. Okay. Specular, KS. Okay. These are all, we call it as reflective coefficients. Okay. We call it as a reflective coefficients. Okay. The next one, GL underscore shininess. Okay. So normally we can see this one in a specular terms, shininess coefficient. Okay. The next one, emission. Okay, emission, which is used for emitting the color, okay, to that particular vertex. Okay, so these are the parameters. Okay, these are the commands for the material. Okay, now next one, we are using one more function called GLU lookat. Okay, so GLU lookat, it's a kind of viewing transformation function. Okay, in which it will hold nine parameters. Okay, those were I underscore x, I underscore y, z, at underscore x, y, z. Then next one, vx, vy, vz, where vx, vy, vz are nothing but view up vector. Okay, view up vector with respect to x-axis, y-axis, and z-axis. Okay, so what is the meaning of this one? So take this particular figure. Okay, so here this particular pinhole camera, I hope you have seen this pinhole camera. Okay, otherwise you can consider a normal camera. Okay, in the normal camera we have a small hole, right? So whenever we click the button, okay, on that it is going to open up. Okay, for a fraction of a second, again it is going to close, right? So whatever the image is there in front of it, it is going to capture. Okay, so now that particular point, okay, this particular point, we call it as a eye. Okay, eye. Okay, or we can call it as a center of projections. Okay, center of projection. So here it is a eye with respect to x-axis, y-axis, and z-axis, means a particular coordinate frame can be drawn. That frame we call as a viewing frame. Okay, viewing coordinate frame. Okay, so the location of the viewer is here. Okay, and this is the object this particular camera is looking at. Okay, this is looking at this particular point. Okay, hence we call it as a at underscore x, at y, and at z. Okay, so at x, at y, at z means with respect to x-axis, y-axis, and z-axis. Okay, this particular camera is looking at. Okay, so whenever we are using this eye or central projection and at, okay, this two is not sufficient. Okay, we have to include one more, that is a thing but view up vector. View up vector is the thing but it is a dot product of I vector and at vector. Okay, so they are always orthogonal to each other. Okay, so here this up vector is nothing but whenever I want to see the image which is there in front of me, I have to tilt my head upward. Okay, means I have to tilt my head upward, means towards the y-axis I should increment. Okay, hence we are calling it as a view up vector, as the name itself says, view up vector. Okay, so this part I have already explained. Okay, so some of the geometrical objects, okay, in the glut. Okay, so in the program we have used the teapot. Okay, Okay, so we have used the teapot. In the teapot, we are going to use the command. Okay, this is the prototype. Okay, this is a prototype of your command. So we have used a glut solid teapot. Okay, and it is going to take the size. Okay, size means if you give 5, 5 means towards x-axis 5, towards y-axis 5, and towards z-axis 5, it is going to increase. Okay, so here the texture of this particular teapot is filled. Okay, means it is, we can feel that a kind of covered one. Okay, kind of a texture based output we can see. Okay, if in place of solid, if you put wire, a kind of tessellated form of teapot you are going to get. Okay, so in our program, we have used this teapot. Okay, and once you get the output of this teapot, in wherever you have this teapot, in that place you can use some other objects also. Okay, you can go with the torus. Okay, you can go with the cone. Okay, you can go with the cube. Okay, and you can go with the sphere also. Okay, if you want to see some, if you want to see, okay, the output of those. Okay, so sphere is nothing but a glut solid sphere. Okay, it is going to draw the sphere. Okay, sphere like this. Okay, so this is the solid. Okay, this is the wired one. Okay, so it consists of 3 parameters: radius, slices, and stacks. Okay, so radius is nothing but radius of the sphere. Slice are nothing but the subdivision around the z-axis. Okay, slices. Okay, these are the slices. Okay, and this is the stacks. Okay, I hope you can link with your what I can say, latitude and longitude. Okay, same fashion. Okay, okay, and whatever this wall, then the table legs, okay, whatever that we have used, okay, that have been used with the help of this cube function, glut solid cube. Okay, so again size is the parameter. Okay, so in place of a glut solid cube, if you want to use a wire cube, you can get, but you are going to get a kind of wired one. Okay, so similarly, you can apply the cone. Okay, so glut solid cone, glut wire cone. So it consists of base, height, slice, and stacks. Okay, so this is the solid one, and this is the wire framed one. Okay, this is the slice, and this is the stacks. Okay, it's height and base. Okay, so this is your and along one more, that is a torus. Okay, torus, again, that r inner, radius outer, sides, and rings. Okay, okay, once you perform, you are going to get the output like this. Okay, it is better that as I said, that this particular program does not have any kind of algorithm. Okay, I want you should try, okay, these particular objects in place of that teapot. Okay, and try to change the values. Okay, try to change the values of that particular light. Okay, then next one, material. Okay, you are going to get a deferred output. Okay, so here completes your teapot program. Okay, I want you should execute this program. Okay, okay, thank you.